Originally, I was going to start out by telling you about this really cool research that came out of Rice and Brown University.
Well, there's some good news. So researchers from Rice University and Brown University have discovered something that can help.
About how they're bending waves to give you better signals. And as I was reading and as I was watching this video that I was going to make for you, which I'll play for you anyway, but as I was reading it, I realized that we need to talk about terahertz waves for a second. Because when you're reading this study and you're looking at the research that came out of the universities, it's very clear that they're talking about a different type of wave. We're not talking about Wi-Fi waves in your house. So the difference between terahertz waves and the radio frequency waves used by your Wi-Fi router are pretty significant. Wi-Fi operates within the radio frequency part of the electromagnetic spectrum. That's typically at 2.4 gigahertz and 5 gigahertz bands for most home routers. Terahertz waves, on the other hand, range from 0.1 to 10 terahertz, which is orders of magnitude higher. Higher frequency allows for wider bandwidth, meaning terahertz waves can theoretically support much higher data rates than current Wi-Fi technologies. This could lead to ultra-fast communication, far surpassing the current speeds of Wi-Fi. So before we get into this research, I just want to be clear. Because of the exponential increase in data consumption, current Wi-Fi technologies are reaching their limits. So this is where terahertz comes into play. Terahertz waves can reach much higher bandwidths and enable much greater data rates. So there's a lot of research around terahertz waves. But then why are we even bothering with the traditional Wi-Fi communications? Why aren't we implementing terahertz, right? Well, there are a few problems there. Number one, efficiently generating and detecting terahertz waves requires advanced technology that is still underdeveloped. Current methods are either too expensive or too bulky, just not ready for commercial use. And then there's also component availability. There's a lack of off-the-shelf components like modulators, detectors, amplifiers. So these things need to be developed too. And then there's propagation challenges. Terahertz waves suffer from high atmospheric attenuation, especially due to the moisture in the air, which significantly reduces their range. This makes outdoor communication over long distances especially problematic. And then there's obstacle penetration, which we're going to talk about in a minute, and you'll see how this research is really cool because it allows these terahertz waves to get around obstacles. And then there's regulatory and spectrum allocation issues. So there's a lack of regulation. The terahertz band is not yet regulated, so that's a problem. There's also a problem with spectrum allocation. We need to determine the best segments for different uses. Then of course there's economics. The development and deployment of terahertz communications is pretty expensive. And then just to add to that, we'd need to do a total infrastructure overhaul. We need to integrate terahertz technology into our current communication systems, transmitters, receivers, all of that. But there is ongoing research. So with that all being said, here's what's going on. We live in a pretty connected world. Our devices are basically, see, it's going off now. Our devices are our lifelines. We've got IoT devices, connected TVs, we've got things we use for work, security, we're just filled with devices. But in order to get those devices to work, we need a connection, right? The problem is that when you're in your home, let's say, or an office building, but let's go back to our home. When you're in your home, for example, you've got your couches, you've got your pillows, your walls, your dog, I mean, even your children, they're in the way of that connection. Well, there's some good news. So researchers from Rice University and Brown University have discovered something that can help. This discovery has helped them navigate around those barriers by actually bending light. Now, I know what you're thinking. What do you mean bending light? Is that even possible? Well, our devices need more bandwidth. And so these researchers are looking at terahertz waves to help. The fact is, we want more data. Even though we're so connected, we want more data per second, right? And in order to do that, we have to work at higher frequencies. So I'm gonna talk to you like we're talking about, being in the home, but what we're really talking about in terms of this research is something on a totally higher level. If you want more bandwidth, that bandwidth doesn't exist using conventional frequency bands. It's not gonna happen. Imagine you're sitting here, but your connection is bending around the wall to get to you. These scientists created self-accelerating beams. And using these meticulously designed transmitters, they were actually able to orchestrate this dance of electromagnetic waves that has them kind of going around obstacles in the way. Imagine throwing a ball, but that ball, instead of following its predictable path, starts to curve and twist and bend around all these obstacles. That's kind of what we're talking about here. And again, they're doing this with terahertz waves. So hear me out. Let's talk about how this is actually possible from a technology perspective. So here's the beam when there's an object blocking the beam. it shuffles the data from that beam to another beam and then to another beam. So it's kind of like the data is jumping from the waves to get around that obstacle. When you're home, you're probably using a Wi-Fi base station, and that fills the room with wireless signals. So no matter where you move, you're maintaining that link. But when you're working at higher frequencies, that's not gonna happen anymore. Instead, it's gonna be a directional beam, and that beam is gonna have to follow you around as you move in order to maintain that link. And so if you move behind something that's blocking that link, or you move out of the range, but remember that curving the beam doesn't solve all of the problems, it just solves some of them. But what the researchers are hoping is that this research leads to more reliable network connections going forward as we start to, since we want more and more data. The next thing they're gonna do is figure out how far they can actually bend the beams, because that's gonna make a difference as to how useful this will be going forward. Ultimately, what they want to do is create more reliable connections in cities or office buildings where things get really crowded. This breakthrough is more than just a breakthrough. It's a technological leap that's going to take us into the next phase of connection. Don't forget to like, subscribe, follow eDesignIt, come back every week. We're here. Have a great day.